Welcome, everyone. Our session is scheduled for 30 minutes, which includes some time at the end for Q&A. Should you have questions throughout the webinar, please feel free to drop them in the chat to Brian or myself via DM or in the group chat. And in the event that we don't have time to get to everyone's questions, we'll follow up individually afterwards. Additionally, the webinar recording will be made available on our website by mid next week.
All right, let's go ahead and start by introducing ourselves. I'll start first. My name is Brian Cooley. I am an Android engineer. I've been working in Android development for 13 years or so professionally. I've done everything from startups to large corporate environments. So I've seen a lot of different ways of developing apps. And, I've done iOS development as well as Android development. So and just a fun fact, I live along the Gulf of Mexico, a lot of bayous in my area. In fact, my home backs up to one. So often we say I'm living with alligators because they'll come up in the grassy areas behind my fence. It's fun to see, but I don't wrestle them, stay as far away from them as I can. Thanks.
And hello, I am Jordan. I am a product scientist with Product Science, and I have helped to optimize mobile app performance for companies of all sizes. And I'm also an expert in training users to identify mobile performance issues using our product PS Tool. And for my fun fact, I am left-handed.
Great. So we've mentioned product science. Who are we? Product science is composed of professionals from a lot of different backgrounds, and our main goal is to democratize performance in engineering. We do that by building tools that amplify our users' delight, that enable you to build apps that make your users really happy with the performance of your app. And we do that by empowering engineers with tools that really show what's happening under the covers of your apps, so that you can get the best performance that you can out of it. And then when we say democratizing performance engineering, what we're talking about is making performance engineering accessible to people who aren't engineers, so that it makes it easier to communicate what's going on in an app with other stakeholders, and also to enable folks who maybe have never written development code in their life. They can still very quickly look at what's going on and have some kind of insight into what might be slowing down an app.
So now that you've heard a little bit about product science, I will discuss PS Tool. So at the heart of product science are two main components. We have our AI instrumentation, and then we have PS Tool, which is a platform for pre-production performance engineering of mobile apps that allow you to visualize the UI of your app alongside the trace file. And on this slide, you can see the UI of PS Tool, along with some of its key features that make it a solution for performance engineering. PS Tool's first unique feature is its execution path, highlighted in yellow. The execution path highlights the progression of method calls that led to a function's execution. And each function, or slice as it is known in the trace file, has its own execution path. Another unique feature of PS Tool is its video synchronization feature. And using this feature, you are able to visualize the UI of your app synced with the trace file while showing the functions that are being executed while any any actions, UI updates, or other processes are occurring in the app. So you can see your app, and then you can see what functions are being executed to show you that particular screen. And this feature provides solid visual cues that cannot be gained just by analyzing an app's code. And as Brian mentioned, PS Tool empowers you to identify areas of potential optimization, even if you were not the one who wrote the original code, or for me specifically, I'm not an engineer, but I'm still able to help our clients find optimization opportunities within their app using PS Tool. And the three code patterns discussed in this webinar today can all be spotted using PS Tool. Now, let's talk about performance, the universal challenge for app developers. Why does it matter? So these days, there is an app for everything, and companies are always looking for ways to make their app stand out against the competition. To demonstrate the importance of mobile app performance, I'll use an example that should resonate with all of us, at least in a theory. Imagine you're about to miss your flight. You're trying to gather all of your luggage, and you quickly need to call a ride to the airport. You try to launch a popular rideshare app so that you can hopefully make your flight before the doors close and it takes off without you. But oh no, the app is taking forever to launch, and its long loading time is squashing your hopes of making your flight. As a last-ditch attempt, maybe you close the rideshare app and opt for one of its competitors. This app then launches immediately, and you are able to schedule your ride to the airport within seconds. So now you manage to schedule your ride, and you also make your flight, which this makes you now a loyal customer of the rideshare app that helped you get there. So this is just one of many examples where good performance can help increase an app's users and loyal customer base, while bad performance can turn potential users or even longtime users away.
Thanks, Jordan. I really like that example a lot. I think we've all, had that sort of visceral experience, that frustration when we can't get something done that we really need to get done right now, or only have a few seconds to look at something important to us. And in contrast, we've probably also had that experience where it just feels magical that you were able to do something so quickly and easily that you couldn't have done before without your smartphone. So, but for those of you who want the cold hard data to convince you rather than just an anecdote, we have that as well. And so let's talk about some statistics around improving user satisfaction. So the first one we have is comes from mobile marketing analytics vendor AppsFlyer, and what they found was that nearly 1 in every 2 apps are uninstalled within 30 days of installation. So the churn is real. Similarly, a study by Andrew Chen found that losing 80% of your mobile users is normal for all but the most popular apps. And I think, that's certainly something that happens for me. I go through my my home screen very often and start deleting apps that don't perform well or that I don't use very often. So it's important. You're going to lose users unless you're performing well, for sure. And a big reason for the high rate of abandonment is typically bad user experience, slowness and unreliability in particular. There's also a study by ThinkStorage Now that found that 70% of mobile app users will abandon an app that takes too long to load. So a lot of folks that develop apps focus on app start, and that's a really critical one because it's one of the biggest influences and definitely the first impression that your app makes on your potential users. And then finally, an older but often cited CompuWare study found that 84% of app users will abandon an app if it fails just twice. So the bar is high, and the first impression is important. So you want to try to have your app performing as well as you can when you roll out those new releases. And so the bottom line is that it's a competitive and crowded market, and mobile app developers have to offer continuous availability and frictionless user experience to minimize their churn. Monitoring and maintaining mobile apps has a lot of unique challenges that are different from say, back-end type services. Mobile apps run on a wide range of devices. It's difficult to get clear visibility into what's going on the client side. Shipping, mobile apps updates takes time and requires oversight from, the App Store or Google Play Store. And it also requires opt-in from users to download them. So you want to ensure that your app is consistently delivering a great experience for your users. And to do that, you really have to monitor how your app performs as well as how your users are interacting with it. And you want to have some idea of what sort of errors they're experiencing. And, the bottom line is it's a different life on a phone. If you're on the web, if you're sitting in front of your laptop or your large monitor with a keyboard and a mouse, you might accept, waiting a few moments for after an interaction. But on a phone, a lot of times you're on the go, and you really expect apps to be almost immediately responsive. And it's really important, even of shaving a few hundred milliseconds off of completing a task makes it seem to be a lot faster and snappier. All right, so with that said, let's dive into the patterns. These are, a couple months ago, we did a similar webinar talking about, 5 of the most common patterns. If you want to call that like mobile performance 101 or 101, this will be mobile performance 102. We're going to go into a little bit more, not obscure, but maybe not the most common apps, but still very important and often very difficult to identify. So the 3 that we have today would be you make a network request, but after you get the network request, you're not processing it in the UI queue because it's not prioritized, and so there's some avoidable delay. Another one would be simply executing a function too many times, more times than you intended. And then finally, when you're trying to display some kind of media, waiting too late to load it so that there's a noticeable lag as the user waits for buffering to finish. So let's go ahead and dive into these.
Thank you, Brian. I'll start by discussing the first code pattern. And the first code pattern that we see is when a network request is scheduled and it executes, but its results are not processed in the main thread queue until much later. And notoriously, we always suggest to schedule network requests to execute as early as possible so that any processes or UI updates dependent on the request are not delayed. However, it can be the case that even though a network request is scheduled and carried out as early as possible, its results are not processed and reflected in the main thread queue until much later. And this is usually due to the main thread queue being busy carrying out other tasks that were scheduled earlier. And delayed processing of network request results can also lead to delayed UI updates if the view update relies on information from the network request. So here on the slide, we see that a network request is being executed in thread 2, but there is a delay processing the results in the main thread. And again, this could be due to a number of things, but it's likely due to just a busy main thread queue. The main thread notoriously always has a lot going on. So there just may be some processes executing that are blocking the queue at that time. So here we see the delay in red between the network request and when its results are processed. And we also see on the diagram that as a result of this processing delay, the UI update is also delayed because it is dependent on the process results from the network request. And to get a few possible solutions to this and further insight, we can get the engineering perspective from Brian.
Thanks, Jordan. Yeah, so like you said, this kind of delay almost always occurs from just doing too much on the main thread. So our focus is going here, as far as solutions, is going to be trying to, how do we get stuff off the main thread? So, obviously first thing would be if you're doing some computations that don't have to be done on the main thread, you want to try to offload those onto a background thread. Another would be that maybe you have, say, a tab view and you're inflating a bunch of layouts that aren't going to be shown. possibly you could defer some of that work until later, until it's actually needed. And then finally, we see this delay sometimes with live data where the business logic goes through a live data. Well, live data runs on the main thread, so you're introducing that bottleneck to your logic. So basically, by the time you hit something that like a live data that has to process on the main thread, you want to be done with all of the kind of processing you can do off of the main thread before you get up there and try to contend for the limited resources. And just to show you an example of the first case where you're talking about moving things onto a background thread, there's a blog post that Gabriel Peel, the main contributor to the Lottie Android animation library, made a couple of months ago, and I've provided the link at the bottom of the slide here. But the basic idea was animation. The Lottie animation library, like most animation libraries, works in two phases. One is to update to figure out where everything has to be positioned on the screen, and that's a lot of mathematical computations. Basically, they don't have anything necessarily to do with updating anything on the screen. And then there's a draw phase, which is usually much shorter and much faster. And Lottie was doing all of the updates prior to the draw on the main thread. So you can see here in the image that the update is several times larger than draw. And the improvement to this latest Lottie release was to move that to a background thread. Now, it did introduce some complexity in having to deal with concurrency and locks and that sort of thing. But the end result for the user is much better, because now the main thread has a lot of cycles that are free for it to do the important work of updating the screen and interacting with the user. Let's go on to the next pattern.
So although not as common as the first one, another code pattern that we have seen is when a function or process is triggered more times than it should be. And one example of this code pattern is when the completion of a network request triggers the view model to update the UI more than once. So as shown on the slide, here we have two images that show the two execution paths for UI updates 1 and 2. So UI update 1 is dependent on information from the network request and the epoxy controller 1, which will build the view model for the UI update. UI update 2 is dependent on information from that same network request, although it's separated for ease of viewing the execution path. And it's also dependent on epoxy controller 2, which will build the same view model as epoxy controller 1 because it is triggered as a result of the same network request. So thus, we see here that there are two epoxy controller slices, both responsible for building the view model for the next screen. And we also see that as a result, we have two UI updates that are essentially showing the same thing because it's all getting information from the same network request. And when a function or process is triggered too many times, the user may see something like a screen refresh or a UI update to show the same screen or screen element more than once. And this is an issue that can affect an app across multiple user flows when loading different screens, if, for instance, they follow a similar pattern of execution to update their view model. And once the function that triggers the duplicate process is identified, it can be a quick fix and can greatly improve the performance of a mobile app. But it's all about identifying what is triggering that duplicate process. And to get the engineering perspective on this, you can hear from Brian.
Thanks, Jordan. Yeah, so like Jordan mentioned, having a view model trigger UI updates multiple times is very common. There's some other things like sometimes you execute an action in on create, and then you have something similar in, say, on resume, so that you're updating your screen when the user returns from another activity or from the background. And that will, on the initial creation of the app, it can cause that, whatever function to be called twice, and might seem like, oh, I would never do that, but believe me, we've seen this happen. So more common than you would think. There are a lot of other, I guess, sort of obvious in retrospect kind of things you can do, like maybe you have callbacks and listeners that you should have unregistered, that you forgot to unregister. Maybe you're misunderstanding what events will trigger a certain callback function. Maybe it's designed to be called multiple times, like a flow or something like that. And then probably the most infamous right now with the rise of the Jetpack Compose UI library are recompositions in Jetpack Compose. And just to show you what I'm talking about here, I have some sample code on the right side of the slide. And what it shows is that you're trying to build a list and you want to have a button that shows up once you scrolled away from the top. So we have this code called show button, which is computing a true false value of Boolean. And it's based on the list state first visible item index, which is something that's provided by the lazy list in Jetpack Compose. And what happens in the first case is that every time you move, you scroll any amount in the list, the lazy list, it's going to recompute that value and recompose this composable, because it doesn't really know if you care, what do you care if the value is 0 again? Should I recompute it again? So Compose has a special has a special method called remember and derive state, which allows it to avoid recomposing the composable, except for instances where the derived state actually changes value. So that's kind of a detail of Jetpack Compose. It's not really a important, like it's not a fundamental performance insight, but what it does emphasize is this fact that that you might have a mental model that doesn't match what's happening in reality, and you need a tool that shows you, what's really going on. And so, that's what product science tooling is all about, is trying to enable you to see what's happening, behind the scenes. Okay, I think we can go to the last one.
Great. Okay, so the third and final code pattern to discuss has to do with delayed media loading and processing. Images, GIFs, and videos are all a big part of some of the most popular apps on the market. And nowadays, users have high expectations when it comes to an app's performance, as we've discussed. And no one wants to use an app where they are constantly having to wait for images and video to load. And one code pattern that is actually pretty common that we've seen, especially with apps that utilize a lot of media, is that the media fetching and decoding is not properly prioritized. So oftentimes we will see the following pattern when loading a screen that features any kind of media. So there will be a network request that will fetch any necessary data for the next screen, and those network request results will be processed in the main thread, and the view for the next screen will be prepared. And we can even see on the slide here, we see where the view preparation is occurring in the main thread. And then after the view is prepared, we then see another network request, also shown on this slide, which is scheduled to fetch the media, which could be images, videos, anything. And then after the request completes, the media then has to be decoded. And then after the media is decoded, the UI will update to show the media on the screen. And this pattern results in a visual delay for the user because they have to wait for the media to be fetched and decoded after the view for the next screen is prepared. So normally when we see something like this, our recommendation would be, instead of scheduling the network request to fetch the media after the view preparation has completed, this can actually be done in parallel. So by fetching the media in parallel with the view preparation that's going on in the main thread and also potentially decoding it in parallel with that view preparation. It eliminates the delay that users see while they're waiting for the video to load, because all of that is happening in parallel with view preparation. That way the UI update can occur much faster and you don't have to then wait additional time to fetch the image or video and to decode the image or video. And we'll hear from Brian to get the engineering perspective.
Yeah, exactly. Jordan has it hit the nail on the head here, that it's important to start loading. This data takes a long time, so we need to start loading it as early as we possibly can. And a good example of that, which I'm showing here in this demo, is an ExoPlayer. So ExoPlayer has a couple of methods for getting a video going. One is to play it after you have a video view available. There's another method called prepare, which you can, and also a prepare async, which you can execute that with just a player. You don't actually need a view to be able to draw it into. So, you know, what we're showing here in the GIF is that the video at the top has been prepared prior to this view, activities view appearing on the screen, while the controller or the video below has just executed the play method once the video view has been prepared. And you can see, if you watch closely, that the video on the bottom is actually like maybe a couple of seconds behind the video on the top. So and there's all sorts of ways this happens. A very common one is if you have a master detail, or the main list view, and you tap on an item and it takes you to the detail view. Then a lot of times, in a tutorial, it'll teach you to load any of the images for the detail view after the detail view is created. Well, there's nothing that stops you from starting that loading, once the item in the list is these are just ways you can kind of think outside of maybe the mainstream, and to make your app really feel more magical, that as soon as I tap that item in the list and animated to the detail, everything was already there. I didn't have to wait. I didn't see any progress bars or anything like that. It's really, like we said at the beginning, we want your users to be delighted, and that's the sort of thing that makes people really happy with your app.
Okay, so now that we've discussed 3 code patterns, let's review them. So I will rate the code patterns on a scale of 1 to 5 stars based on their impact on user experience. And Brian will do the same, but based on how difficult these code patterns are to identify. So let's start with the first code pattern, where network request processing is not prioritized in the queue. So this code pattern has a big impact on user experience, because when the results of a network request are processed late, any UI updates that depend on the results of that request are also delayed, and this creates a visual delay for users. So because of this, I would rate this code pattern at 5 stars for its impact on user experience, because it has a very high impact on user experience.
Yeah, I think this is a fairly difficult to identify pattern, because I think a lot of times when you write the code to execute a network request and update the UI, you're just sort of, kind of throwing it over the wall to let a library handle that, and you just expect that the UI update is going to happen as soon as a network request returns. So very useful to have some tool that will show you what else is going on in the main thread, and help you identify stuff that can work that can possibly be moved to a background thread.
And for the second code pattern, where a function or process is triggered too many times. So depending on the process, this code pattern can have varying impacts on user experience, because it can cause duplicate behavior that increases a user's overall wait time. But because the impact on user experience really depends on the process or the function that's being triggered multiple times, I would rate this at 3 stars because it all depends on what the process is and how much delay that is causing by carrying it out more than once.
Yeah, and I think this one is a tricky one because, like I said, sometimes you don't have the right mental model for how things are called, or I mean, you're certainly not calling functions needlessly, intentionally. So, so I'd give it 4 stars, and you know, again, really helpful to have some tool to show you what's going on as it's running.
And then the final code pattern where we have delayed media and loading and processing. So this is another code pattern that can have a big impact on user experience. When a video, image, or GIF is fetched and decoded after view preparation has finished, the user will almost always experience a delay for however long it takes to fetch the image and decode it, and then update the UI. So because of this, I'd rate it 5 stars for its impact. And because, well, you know, we're all visual people, delayed images in media is the first thing that users will notice when they load a screen. So that's why it is rated at 5 stars, because media is a big part of many apps.
Yeah, and for loading media, I think this is one of the easier things to identify. You know, you see it buffering, you see the progress bar spinning. It's really more of a instance of you have to try to get outside the box in your thinking and figure out creative ways to start loading earlier. So.
Great.
All right. We do have one question. I guess I think we have some time. Maybe time for one question, which is the question was, with respect to Jetpack Compose, how is the PS Tools recomposition analysis different from the one provided by Android Studio? And I would just say, I mean, they're similar in, you know, what they're going to show. In the example that we talked about during the webinar, it was a pretty simple example, but if you had a more complex flow that, you know, involved maybe like some kind of loading data or something like that, we would tell you more than that tool by showing you, you know, what the execution path is. We also provide video synchronization, so you can locate the parts in the code, you know, from the video that are affecting, you know, causing your stutter or whatever in your app. That's all the questions we have now. So
Great. So this will conclude our webinar. Please feel free to visit us at productscience.ai or to send us an email at hello@productscience.ai if you would like to get in touch. And we also have our LinkedIn information here on the screen if you would like to message us directly on there. Thank you all for joining.